All right, welcome back. This is Big T, and I'm here with Wolfie. Ow, ow, ow! That's right, Wolfie's excited. We're gonna be doing another math vid. Ow, ow! Oh, Wolfie, you didn't realize. I'm sorry. Well, let's get ready to hop in the bus. And yeah, speaking of buses, have you ever noticed that buses stink? Like, they really stink. Maybe it was the kid who was sitting in front of me. Like, what was he eating for breakfast? Rice and beans? Ow, ow, ow! Am I right? Can't you just hold the fart in until we get to school? Anyhow, we're going to be talking a little bit about the sloppy. Ow, ow! Yeah, the Wolfman likes the sloppy. Anyhow, I'm going to have to put on my teacher's voice. I know, Wolfie, it's so boring. But have you ever watched these math videos? Everybody talks in the same boring voice. So I think that's the thing to do. All right. What? Oh, I know, I can't stand it either. Well, it's time. We're going to be talking a little bit about slope today. And if you take a look at the three lines that are graphed, you all can notice they are constant linear line graphs, where the x is going to be increasing at the same rate as the y, and the y is increasing at the same rate as the x. When you take a look at these, we have three distinct lines, the green line, a red line, and a blue line. We can make the conclusion that the red line has the steepest slope. The blue line would have the second steepest slope, and the green line has the least steep slope. What I mean by that is the y is increasing at the least rate, or the smallest rate, each time the x increases. Whereas in the red graph, as the x increases, the y is increasing at a greater rate. So we have a very steep incline. We're going to go and apply this concept in terms of finding the slopes from different graphs. If we take a look at something like the speed of a motorized car, we've been finding slope all the time, just disguised as different names. So when we take a look at this, we have a car. Let's say along the x-axis we have time. Along the y-axis we have distance. Well, the slope, in this case, we've always referred to it as speed, or centimeters per second. But what we're really finding is at what rate is our y-axis, the centimeters, increasing, as our x-axis, the time, is increasing by 1 unit. For every 1 unit of increase along the x-axis, by what is the y-axis increasing? So we can go ahead and make a little function table, x, y, as our x is, and we have to find points that work really nicely. So I could take, let's say this 4, 50. It's a nice intersection on the line. When x is 4, y is 50. And I could jump ahead to a next point along the intersection. When x is 8, y is 100. And we've always referred to this as speed. How many centimeters is your car going for every 1 second? But we can look at it, we're going to look at it the same thing in just a different way, and we'll come to the same conclusion. As our x is increasing by 4, our y is increasing by 50. So our question is, for every 1 unit of increase along the x-axis, what is the y-axis increasing by? And we can see it to x to y, we have a ratio of 1 to 25. So we would say, if you were writing this out in speed, you would say it's 25 centimeters per second. But when we're talking about slope, we would say the slope is 25, or the slope equals 25. Slope is a more generalized term, so don't get caught up in the units. We've been working with slope in a lot of different ways. Slope is speed. Speed is change in y over change in x. We just haven't always looked at it in the same way as a graph. So as the x increases by 1, the y increases by 25, therefore the slope is 25, therefore the speed is 25 centimeters per second. when you take a look at a graph that's like this, if we're saying the movement of a turtle, it's not such a constant speed anymore. So you can't generate one slope for this graph. Just like if we were talking about speed, it would have multiple speeds. It would have a speed along this interval of time, along this interval of time, along this interval, and in the same way, there are multiple slopes. Once again, this is a speed example. In this case, we're talking acceleration. Acceleration is the same thing as slope as well. By what does the speed increase for every 1 unit of time? And we would have our own slope along here. And here we would have a negative slope or a decreased slope. So it's not a very difficult concept if you've worked with speed before or acceleration, because slope is just a more generalized term for the same thing, just not taking into account units. So if we're looking at this graph right here, and you're said to find the slope, always start off by, let's find plottable points. If I take a look at 0, I can tell when x is 0, y is 2. In this graph, I can't just increase x by 1 because I can't be precise. I don't know what my y value is when x is 1, but I do know what my y value is when x is 2. When x is 2, y is 5. Because this is a linear graph, I only need 2 points because the y is going to increase at the same ratio as the x increases. So I could go ahead and find when x is 4, y is 8, but I don't even need that. Already, from what I've plotted, I can see that as my x is increasing by 2, I'm going to write a plus 2 to signify an increase, my y is increasing by 3. So the question becomes, as our x increases by 1, think about centimeters per second, you're getting it to a unit rate. Slope is per unit. For every increase of 1 in the x, what is the y increasing? So if we have a y to x is a 3 to 2 ratio, as if x is 1, then we're dividing by 2, and 3 divided by 2, you could just call it 3 halves, or 1 and 1/2, or 1.5. And so the slope for this graph is 3 halves. You can write 1 and 1/2, or you can write 1.5. It's all the same thing. And if you were to look at it and say speed, we could see, yeah, the speed is 1.5, if we had units, would be centimeters per second. What is the y increasing for 1 increase along the x? And it would be increasing at a greater rate of 1.5 for every 1 second. So not a tough concept if you're able to think about it kind of as speed each time. Same type of situation, although we can see this slope, just by looking at the graph, is a little less severe. As the x increases by 1, what is the y increase? That's the slope. So far I can find a point when x is 10, y is 10. I'm only going to find 2 points this time. This doesn't help me, doesn't help me, doesn't help me. Okay, when x is 50, y is 20. So for every increase of 1 in the x, what is the y increasing? Well, here we have an increase of 40. And the y is only increasing by 20. So if we were, you'll often see it expressed as change in y over change in x, but we're looking for every increase of 1 in the x, what is y increasing? So right now we're at 20 to 40, which can be simplified as 1/2. So the slope in this graph is 1/2. Y is increasing at half the rate. For every one increase of x, y is increasing by 1/2, or it would be 0.5 centimeter per second if you were thinking about it as speed. We'll take you through a little tougher one. Now, if you're not given the graph, but you're just given points, so let's say find the slope of a line that passes through 3, 7. So you're going to have to go ahead and plot these points. And it passes through 8, 1. What's the slope of this graph? Well, if we connect it with a line, it looks like this. But remember, and just by looking at it, you should be able to tell if we were talking about acceleration, deceleration, this is a deceleration. Meaning that the slope is going to be negative. So we already have our points, which makes this a little bit simpler. But the visual helps you realize that we're having a negative slope. When x is 3, y is 7. When x is 8, y is 1. So when our x increases by 5, our y is decreasing by 6. So if we were to look at this and say change in y over change in x, for every one increase, and this time I'm just going to do a different strategy. When x is 5, I can make a little table here, y is -6. When x is 1, because that's the question, what is for every one unit of change on the x, what is the y changing? To go from 5 to 1, we're dividing by 5. Whatever you do to one side, you must do to the rest. -6 divided by 5. And I'm just going to leave my answer as a fraction. The slope is -6/5. Or that -1 1/5. However you want to represent it. But you can just leave it as a fraction as well. Go ahead and practice these next problems on your own, and then I can review them if you would like. So pause this video, find the slope, and then press play and check your answer. In this case, our slope is when x is 3, y is 9. When x is 0, y is 8. So 0 along the x, y is 8, 3, 9. X is increasing by 3, y is increasing by 1. So if I'm going to do xy, it would be 3, 1. For every 1 increase along the x, divide by 3, y is 1/3. That's the solution. Next problem, solve this one on your own. Press play when you've reached a conclusion. Okay, I will go ahead and solve it right now. The points I'm going to choose are when x is 3, y is 2. When x is 6, y is 6. So x is increasing by 3, y is increasing by 4. So when x is increasing by 3, y is 4. So for every 1 increase along the x, divide by 3, the y is increasing by 4/3 that, or 1 1/3. Last problem for you to go ahead and practice. Or maybe we'll do 2 more. Just pause it and practice. Okay, I'm going to solve it now. When x is 50, y is 20. When x is 70, y is 50. So as x is increasing by 20, y is increasing by 30, which means 30 to 20 is 3/2 or 1 1/2 for the slope. Okay, this will be the last problem. Go ahead, pause the video, read it, and then solve it, and I will review. Find the slope of the line that passes through 7, 6.